This is Chapter 13, Problem 13. The question reads, Plaskett's binary system consists of two stars that revolve in a circular orbit about a center of mass midway between them. This means that the masses of the two stars are equal. Assume the orbital period of each is 14.4 days. Find the mass m of each star. And they tell you that the mass of our sun is 1.99 times 10 to the 30th kilograms. So in order to, basically what we're given is that the orbital period is 14.4 days. The orbital speed, based on the diagram, is 220 times 10 to the third meters per second. They want you to find the mass of each star. In order to find the mass, we must refer to Newton's second law. So Newton's second law states that the sum of all forces is equal to mass times acceleration. But what you also learn in this chapter is that the force of gravity is equal to mass times the centripetal acceleration. So the force of gravity is given by this equation, and then the centripetal force is given by this equation. So basically, because they're both forces, you just make them equal to each other. And then, because you're trying to isolate the value of the variable m, it comes out to be this. This is the equation that you will use. So this is the equation that you use, and then you know that you can substitute for r. You can substitute vt over 2 pi, and that gives you your new, again, since r is equal to vt over 2 pi, and so that reduces over to this equation. Now using this equation, you plug in your value, which you do have v cubed based on the diagram. You were told that the period, which would be the capital T, is 14.4 days, and you know the gravitational constant is 6.67 times 10 to the negative 11th newtons times meters squared over kilogram squared. Then it becomes this equation plugging in all the values. And again, because it's 14.4 days, but your answer needs to be in kilograms, you have to do the unit conversion here as done at the 86,400 seconds in a day. So again, this is all the values that you plug in based on this equation right here. And then if you plug that all in your calculator, you should come out to get that the mass is equal to 1.26 times 10 to the 32nd kilograms. And because they want the answer, they could possibly want the answer in solar mass units as well. What you would do, you'd divide 1.26 times 10 to the 32nd kilograms divided by the mass of our sun, which is 1.99 times 10 to the 30th kilograms, and you get your answer of 63.3 solar masses. So either one of these values should work in either kilograms or solar masses.